Hey guys, Mr. Gron, happy Friday. Today we're going over inverse trig functions. Now this is something you guys have done before with the unit circle. However, we're going to look at it a little bit differently. We're going to add a little bit of stuff to it. So first thing, a little bit of vocab that might be new. We're going to see problems that use both inverse function notation as well as ARCSINE, ARCCOSINE, and ARCTANGENT. It's the same thing. It might be something that you see in a future class, so we felt it's important that you see it here so it's not brand new when you see it in the future. Not that it would be that hard to figure out. Oh, so one thing. We're going to be talking a little bit about the graphs of an inverse trig function, so ARCSINE or sine inverse. If we think back to the graphs of inverses of functions, what happens is this. If we take our normal sine graph, kind of looks like this, right? Taking an inverse flips it over that diagonal line. What happens then, what the graph looks like, is this. And what you might be thinking is if we're talking about functions, that this is not a function because it doesn't pass the vertical line test, and that's true. So what we're going to have to do is restrict the range, and this is going to affect how we use the unit circle. So for sine, for instance, we're just going to look at like this little section so that all of the values from -1 to +1 are represented in that restricted range. And it's similar for sine and cosine. I mean, for cosine and tangent. Okay. So just a couple little notes on inverse trig functions. Remember that what these actually do, a sine function takes an angle and gives you a sine ratio. The inverse takes that ratio and gives you the angle that's represented by that ratio. So it's basically using the unit circle backwards. Again, in order for inverse functions to be functions, the range needs to be restricted, and that range restriction depends on the function. So going through each function, for ARCSINE, our domain is from -1 to 1, the same as the range would have been for sine. The range, though, gets restricted from -π/2 to +π/2. That means on your unit circle, you're looking at quadrants 1 and 4. In quadrant 4, we're going to have to adjust the radian values, the angle values on that a little bit. And it's not tough. We'll see it after we go through these. This is what the graph looks like as well. So it's one little section of the sine function when it's been turned vertically, right? All of this represents all of the possible output values, all the possible y values from the unit circle. So from -1 up to +1, only now those are the x values. Cosine, same idea. The domain is the same, -1 to +1. The range, now we're going from 0 to pi, meaning we're going to go from quadrants 1 to 2 on the unit circle. And I'll explain a little more about that when we look at the unit circle itself. So this is what our graph looks like. It's just this little chunk here that goes from -1 at pi down to +1 at 0. All right, and then tangent. If you remember the tangent graph, it looks a little bit different. So it's a bunch of these, right, is what a tangent graph looks like. It's a bunch of these sort of curves. And so if we flip that on its side, now it's a bunch of these, a bunch of layers of these types of curves. And so if we want to make it a function, we just choose one of them, and we choose the one that's in the middle just for simplicity's sake. The tangent graph originally has vertical asymptotes at pi/2 and -π/2. And so when we take the inverse of that, now those vertical asymptotes become horizontal asymptotes. All right, so in summary, A couple of things to try to remember with this. Sine inverse is only defined in quadrants 1 and 4, cosine in 1 and 2, tangent in 1 and 4. And those Q4 values, quadrant 4 values, are going to be negative instead of the unit circle values. So we're going to take some negative coterminal values when we're working with this. And here's what I mean by that. Look at that fancy animation. So with sine. Sine is the y value from the unit circle. So inverse sine takes that y value and now that is the output. For sine, we're choosing quadrants 1 and 4 to use. The reason that we're using 1 and 4 and we're restricting it, 1 and 4 represents all of the possible y values from -1 all the way up to +1 that could come from a sine function. So that's why these two are sine. Same thing with tangent. If we divide these two, that's going to give us all of the possible tangent ratios of all of the possible angles as well, positive and negative. All of these ones would represent the positive tangent ratios. All of these ones would represent the negative tangent ratios. It doesn't matter if they're from here or here when you flip the x and y being negative, because it's going to be a negative over a positive or the same positive over a negative. It's going to have the same tangent value. So those two are tangent. Cosine then, the original function of cosine uses just the x value. So if we look at the possible outputs from the unit circle, all of the possible x values can be represented in the top two quadrants, 1 and 2, going from -1 and then all the way through to +1. So that's why cosine is these two quadrants instead of sine and tangent being these two. All right, so actually using these. First example, we're going to go over these 6 with the unit circle. Another fancy animation. This is one thing that you're going to be doing. The next one is going to be a little bit tougher where we're doing sort of a double problem. But we'll look at these first. If you want to pause this and just see if you can do it, because this is technically a review, go for it. Or pause it any time along here if you see one of these and you're like, yep, I think I got it, and then try the rest of them and unpause it. I'm going to try to buzz through these fairly quick so I can get on with my morning. Okay, so first thing, with the unit circle, when we're talking about quadrants 1 and 4, we said that these have to be negative because we're defining the range as being not from 3 pi over 2 to 2 pi, then starting over at 0 and going up to pi over 2. We want that to be continuous. So we said this is negative pi over 2. That means that this one is now negative pi over 3. So it's this one going pi over 3 positive is right here, going pi over 3 negative would land you right here. So this is the negative coterminal angle to 5 pi over 3. Then negative pi over 4 and negative pi over 6. These are the values that we're going to be using for these problems. Okay, inverse sine of root 2 over 2. Sine goes with the y value, right? So you were looking at what angle has a y value of root 2 over 2, and because we're talking about sine, we're talking about quadrants 1 and 2. Right here, that's our y value of root 2 over 2, so that's pi over 4. Arcsine of negative root 3 over 2, again, this is the y value that we're talking about for sine. So we're just finding where is the y value negative root 3 over 2. It's negative root 3 over 2 here, and because we've got that range restriction, it's not 5 pi over 3 for this, it's actually negative pi over 3. Cosine inverse. Cosine is the x value, so where is the x value equal to 1? Cosine, we're looking in the top half of the circle. X is equal to 1 right over here at 0. cosine negative 1, or cosine inverse of negative 2. So where's the x value equal to negative 2? Well, the minimum x value is negative 1. Negative 2 would be over here. It's not on the unit circle. So this one is undefined. Tangents. This is where they get a little bit tougher because now we have to think about where is y over x equal to root 3 over 3. This could take a little bit of trial and error at first, but if you practice enough of these, the same values come up over and over again, so it becomes not a big deal. All right, so first off, it's positive, right? Root 3 over 3 is positive, so that means it's got to be in this quadrant. Let's just say, for instance, I don't know which one to pick. Well, I'm obviously not going to pick this one. It's not going to be 1 over 0. It's not going to be 0 over 1. It's not going to be this one. It's got to be the one that's got one of the root 3's in it. So I can really just pick one and give it a shot. I'm going to pick pi over 6 and see what happens. Let's see. So 1/2. Keep change, flip with the x. So 2 over root 3. The 2's would cancel out. I'm left with 1 over root 3. And now I have to rationalize that denominator for this to work. So some teachers don't stress that in the earlier sections. I do because this is where you need it. So that one worked out at pi over 6. So it's pi over 6. Then arctangent to 1. Again, I'm looking for where is y over x equal to 1. Well, when is a ratio going to be equal to 1? It's when the top and the bottom are the same. If y and x are the same, then it's going to equal 1 because it's the same number divided by the same number. And that happens right there at pi over 4. All right, so now some more difficult problems. These ones aren't too bad, these first 4. We're going to go through 10 of these total. But these are the double inverse problems. The way we want to think about this is simplifying what's in the parentheses first and then simplifying what's left. We really have to try to keep things straight here, whether we're starting with inverse trig or regular trig. If you're given a value that's from the outside of the unit circle, one of the coordinates, your answer is going to come from the inside, and vice versa. If you're given a radian on the inside, your answer is going to come from the outside. So just, don't get overwhelmed. Just think your way through it. These actually aren't that bad. They're kind of fun. Okay, so the first one, sine of arcsine of 1/2. Some of these are just going to cancel each other out. I would encourage you not to do that because there's ones that don't cancel each other out, and it ends up not working out very well if you try to do that. So, arcsine of 1/2. We're looking for where is the y value equal to 1/2. It's sine, so we're looking on the right side of the unit circle. Y is equal to 1/2 right here at pi over 6. So the first step to this, we can reduce this to sine of pi over 6. Now we're taking sine of pi over 6, so now the question is, what is the y value at pi over 6? Which is 1/2. So this is a case where sine and arcsine just cancel each other out. That's mostly going to happen in this slide. The future slides, not so much. Okay, so now sine inverse of sine of pi over 6. Really the same problem, but backwards. Again, pi over 6 comes from the inside of the unit circle. Sine is the y value, so the question in the parentheses on that one is what is the y value at pi over 6, which is 1/2. So the first step here is that this is sine inverse of 1/2. Now it becomes where is the y value 1/2? What angle has a y value of 1/2? Well, we just kind of showed that was at pi over 6. So another one where they just cancel out. Going to be the same thing here. Cosine of pi over 3. We're looking for the x value at pi over 3. Pi over 3 is there. The x value is 1/2. So the first step for this reduced to cosine inverse of 1/2, then, now that it's cosine inverse, now you're asking what is the x, where is the x value 1/2? X value is 1/2 here at pi over 3. So another one that just cancels out, and it's pi over 3. Tangent of tangent inverse of 1. Tangent, we're looking at where is y over x equal to 1. Again, we looked at that in the last slide, where y and x the same thing. It's positive, so we're looking in this top quadrant. Y and x are the same right here at pi over 4. So tangent to pi over 4. Now the question is, what is the tangent ratio at pi over 4, which is root 2 over 2 and root 2 over 2, so it's x and y are the same, so that's equal to 1. All right, so that was kind of the roundabout way of doing that. I will admit that. However, this is the thought process that you really need going forward for some of the more difficult, more complicated ones that we're going to do in the next 2 slides. All right, arcsine of sine of 2 pi over 3. If you just cancel this out, this lies outside of the range restriction of arcsine. And so if you cancel this out, you are not going to get the correct answer. Sine of 2 pi over 3. That part, if we just focus on the parentheses first, we are asking, what is the y value at 2 pi over 3? 2 pi over 3 is right here. The y value is root 3 over 2. So now the problem becomes arcsine of root 3 over 2. This is asking, where is the y value, root 3 over 2, within the range restriction of the inverse sine function, arcsine. The y value is root 3 over 2 right here, within that quadrant 1 and 4 restriction. And the angle there is pi over 3 radians. So this one is pi over 3. Again, if you would have just crossed it out, you're not coming up with the right answer. All right, next one. Cosine inverse of cosine of 5 pi over 2. Now we've got one where the radian isn't even on the unit circle. We have to think about coterminal angles. So just starting out, cosine is the x value. If we rotate pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. This is coterminal with 5 pi over 2, so this is really what we're looking at. What is the x value right here? It is 0. So the first step is reducing that to now inverse cosine of 0. So now, within the range restriction of just the top half, because it's cosine, so quadrants 1 and 2, where is the x value equal to 0? It's equal to 0 here, which is at regular pi over 2. And tangent. So tangent, arctangent of tangent of negative 5 pi over 2. So now some negative ones. So now we're counting the other direction. That's negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2 is down here. Tangent is y over x. So with that one, it's negative 1 over 0. So tangent of 5 pi over of negative 5 pi over 2 equals negative 1 over 0, which is undefined. Now, common mistake that students make is they think, okay, that means that I can do arctangent of undefined and match up where tangent would be undefined, and that's my answer. However, that would be, it's not bad intuition, but it's not correct either, because all of the other problems, we had an actual number which could be plugged into a function. Undefined is not a number. this would make as much sense as saying, what is arctangent of unicorn? Like, it doesn't. You can't plug in undefined. So this is also undefined. All right, last one. Last three, I should say. So now we've got our combo platter where we're mixing and matching the sine, cosine, and tangent functions. We're mixing them all up. The first set, it was all ones that you could just cancel out, but I didn't because I just wanted to not do that and show you a better way to do it. The last one, it was, you know, matching ones, sine and arcsine, but you couldn't just cancel it out. Now we've got them mixed up. It's really no different. The strategy is the same for all of these. So the first one, sine is the y value, cosine is the x value. First part in parentheses, what is sine of pi over 3? Pi over 3 has a y value of root 3 over 2. So now we're solving that. What is inverse cosine of root 3 over 2? Where is the x value equal to root 3 over 2? Right here at pi over 6. Sine inverse cosine. So again, sine is the y value, cosine is the x value. Cosine inverse of negative root 2 over 2, we are looking for what is the angle that has that x value within the top two quadrants for cosine. X value is negative root 2 over 2 right here, which is at 3 pi over 4. Now this becomes sine of 3 pi over 4. What is sine of 3 pi over 4? It's the y value, which would be at root 2 over 2. All right, last one, sine of arctangent of negative root 3 over 3. Sine is the y value, arctangent is y over x. So where in these two quadrants, 1 and 4, is the tangent ratio negative root 3 over 3. Again, I can do a little bit I can break things down a little bit and eliminate a few things. I know it's not going to be in the top quadrant because these have positive tangent ratios. It's got to be down here where it's a negative over a positive. I know it's not going to be like here, here, or here because those don't have the square root of 3 in them. So it's got to be one of these two. Now, I'm going to take the shortcut. I know it's this one, so I'll test it out. But you might try this one out and it doesn't work, and then you fall back to this one and try it, and it does work. So, negative 1/2, keep change, flip with root 3 over 2, which would make it root 2 over root 3. 2's cancel out. It's negative 1 over root 3. And then when we rationalize that, it becomes negative root 3 over 3. So that was this one at negative pi over 6. Now the question becomes, what is the sine ratio at negative pi over 6, which is what is the y value at negative pi over 6, which is negative 1/2. All right, so that is your crash course on inverse trig. Do some practice with this, ask some questions, be nice to the sub, and or have some questions, I should say, ready for Monday. We'll finish up Chapter 4 Monday and Tuesday, then we'll go on Thanksgiving break. We'll come back and do a day of review and then test on Chapter 4. So good luck, have a great weekend, and I will see you on Monday.